Today we're going to talk about independent and dependent events. So some vocabulary. A simple event is an event that consists of exactly one outcome. Compound events, it's an event made up of one or more simple events. Now with compound events, we can have either independent or dependent events. So let's look at independent first. These are events in which the outcome of one event does not affect the outcome of the other. So this is really important. They're independent of each other. So some examples are rolling a die and flipping a coin. The outcome on the dice does not impact whether it's going to land on heads or tails on that coin. Picking a marble from a bag, putting the marble back, and then picking a second marble. That doesn't change anything because the number of marbles every time you pick out is going to remain the same because you are returning the marbles back to the bag. And then the key phrase you want to think about is going to be events that are with replacement. So again, if we replace something, we are putting it back and the total number of options that we have remains the same. So those are all examples of independent events. Now looking at dependent events. Now these are events in which the outcome of one event does affect the outcome of the other. So what happens first is really going to have an impact on the second thing. Now for example, here, picking a marble from a bag and not putting it back. So I pick one marble out of the bag, keep it out, so then the number of total marbles is one less. So that's why it changes from independent to dependent, because we're changing the number of total outcomes. Then, so keywords here, events that are without replacement, do not replace, or eating something. Because if we're eating something, we're not replacing it back to our options. So these are key phrases we want to remember that signify dependent events. And we're going to want to ask ourselves when reading the scenarios of each situation, ask ourselves, is this going to be independent of each other or dependent on one another? Okay, so looking a little further along, so finding the probability of A and B. Again, and is a key word here. That word and means we're going to multiply the two probabilities. So the probability of A and B is equal to probability of A, so figuring out what that is, times the probability of B. So we're going to multiply those two probabilities to figure out our probability for both to occur. So looking at example 1, you roll 2 dice. What is the probability you roll an odd number and then a multiple of 3? So here we have two situations, so that's why it's a compound. So determine if the events are independent or dependent. Well, if you roll once and then roll again, the first roll has no impact on the second, so that's going to be an independent event. So that is our first step, wanting to find what kind of event is it, independent or dependent. Now second, you want to find the probability of each event. So the first thing was rolling an odd number. So our odd numbers are 1, 3, and 5. So on a dice, there's 6 sides, so that would be exactly half of the option, so 1/2. And again, if you wrote 3 over 6, you always want to simplify before we have to multiply. That way it's less simplifying at the end. The second event was the probability of landing on a multiple of 3. Now the second event, we want a multiple of 3 on the second die. So our multiples of 3 are going to be 3 or 6. So again, multiples are 3, 6, 9, and so forth. But on the die, it's only 3 or 6. So that's going to be 2 out of 6 options, or simplified to 1/3. And again, if you don't simplify now, you'll just end up simplifying your answer at the end. So it's your choice when you prefer to simplify. I like to simplify before multiplying the two possibilities together. So here, I'm going to multiply my first event of 1/2 and my second event of 1/3. So I have 1/2 times 1/3. So you multiply the numerators. 1 times 1 is 1, and 2 times 3 is 6. So my answer would be 1/6. Now looking at example 2, you spin the spinner 3 times, find the probability that it will not land on blue each time. So 3 different spins. So Again, the first spin doesn't impact the second spin or the third spin, so these are independent events. So writing the fraction of probability for not blue for the first time, 3 sections aren't blue, so that's 3 out of 4. Again, same thing, probability for not landing on blue, since independent's going to be 3/4 again, and 3/4 again. So we're going to multiply 3/4 times 3/4 times 3/4 to get an answer of 27/64. Let's go ahead and look at example 3. You pick a piece of candy out of a jar. There are 5 strawberry pieces, 4 orange, 3 grapes, and 3 watermelon. What is the probability of picking a strawberry, eating it, then choosing a grape? So first thing, how many total pieces are there to begin with? We have 5, then 4, 3, and 3. So that's 15 total pieces of candy. Another keyword we want to look at is we are eating it. So that means once we pick it up, we eat it, then the second chance, the total outcome is going to change. So independent or dependent, this is going to be dependent because we are eating a piece of candy before picking out the next one. So probability of getting a strawberry first, well, we haven't eaten anything, so there's 5 strawberries out of a total of 15, which simplifies to 1/3. Now the second event is we want to see the probability of picking a grape after eating a strawberry. So what we need to remember is we now ate a strawberry, so that changes to 4 strawberries, making the total, instead of 15, 14. Okay, so that means grapes, the number of grapes still stay the same. It's still 3, but it's going to be 3 out of 14. And again, that 14 changed because we ate a piece of candy. So we're going to multiply those two probabilities together. So we have 1/3 times 3/14. Multiply across. Okay. You can go 1 times 3 is 3, and then 3 times 14. Or what we can simply do is, if I know that we have both a 3 in the numerator and the denominator, I can simplify that. Those both simplify to 1 when divided by 3, so that makes it easier to multiply across. 1 times 1 is 1, and 1 times 14 is 14. Now, if you multiplied before simplifying here, in our multiplication, okay, your simplified answer would still be 1/14. Now, looking at example 4. You pick 2 cards without replacement. What is the probability of picking a star, now putting it back, and picking a star? So here we're going to pick a star and then another star, and the key word here is without. So that keyword without is telling us that this is going to be a dependent event. So the first probability we're looking at is we have a total of 10 cards, and then there are 4 stars to pick from at the beginning. So the probability of picking the first star is going to be 4 out of 10, which simplifies to 2/5. Now we want to pick another star, but we're not replacing it. So in theory, we can cross one of the stars out. So that means that I only now have 3 stars that are possible to pick out of 9 cards. So I have 3 out of 9, which is 1/3. So we're going to multiply those simplified probabilities. So 2/5 times 1/3. So we get 2/15 as our answer. And again, that keyword without meant it was dependent, so the number of total options we have is changing. So here we started with 10 cards. Once we picked one, our options changed to 9 cards. And because we picked a star and then picking the same object again, the number of that changes also. Looking at example 5, 1 letter selected and the spinner is spun. So we have 2 different things. What is the probability that both are a vowel? So here we're just picking a card at random and then spinning the spinner and seeing where it lands. Now these 2 things do not impact each other, so they're independent of each other. So the first vowel here, we're going to look, we have 2 vowels out of 1, 2, 3, 4, 5, 6, 7 options. So picking a vowel, probability of picking a vowel out of those cards would be 2/7. Now, probability of landing on a vowel on the spinner would be 2 out of 6 options on the spinner. which simplifies to 1/3. So now we can multiply our two probabilities, so the 2/7 times 1/3, and that's going to get us 221. Now, we want to place this value on the number line below. So what we're going to do is change this to a decimal, so I can do 2 divided by 21 and get an answer of 0.095. Now, if we were to round that, that's going to be really close to 0.1. So not exactly 0.1, but definitely close to it, because that 5 would change the 9 to 1 in the tens place. So I'd put my placement really close to 0.1, but not quite. And again, that's just looking if I run around this. So if I'm looking at the tens place value here, that 9 is going to round that 0 up to a 1. Looking at our example 6. So the probability it rains on Saturday is 30%. The probability it rains on Sunday is 40%. Find the probability it will not rain on both days and plot your answer. So first things we want to ask ourselves every time, is this event independent or dependent? Whether it rains one day and the other, in this specific example, is going to be independent. Okay. Now, another keyword we want to look at is it will not rain. The percentages they gave us, the 30 and the 40s, if it does rain. So we're looking at does not rain. So probably it does not rain on Saturdays. It's actually going to be 70% or 0.7. So that's for Saturday. And then for Sunday, it has a 40% chance of rain. So if it's not rain, it's going to be 60% or 0.6. So we can go ahead and multiply these two decimals. So we have 0.6 times 0.7. Okay, and you get 0.42. So a 42% chance for both days. And again, we're going to plot that again. So here we have 0.4, 0.5. Halfway in between would be 0.45. So that's definitely 0.42 will be closer to 0.4 than it will 0.5. And again, you want to make it, to the left of the center of that 0.45. So the next example here says, who has a greater possibility? So we want to look to see if Sam or Kyle has a better possibility here. So for the scenario for Sam is picking a blue marble, not putting it back, and then picking a green marble. So here we are not replacing the marble. So that means for Sam's scenario, it's going to be a dependent event. So that's important to remember. So Sam, picking a blue marble. So there are 4 blue marbles, okay, out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 4 out of 12, which simplifies to 1/3. Now, Sam is going to keep that blue marble, okay, and then see what's the probability of picking a green marble. So that means I'm down 1 less total marble. So there's 2 greens out of 11. And that 11 came from Sam keeping the marble that she picked the first time. So then we have 1/3 times 2 11s. And we multiply that, we get 2 33rds. Now let's look at Kyle's situation. So Kyle's picking a yellow marble, putting it back, and then picking another yellow. So the key word here is putting it back. So if Kyle's putting this marble back, that means these two events are independent from each other. And that's because the total number of marbles, the 12, is not changing every time you do the events. So probability of picking the first yellow is going to be 3/12 or 1/4. Probability of picking another yellow when you replace the yellows is going to also be 1/4. So you have 1/4 times 1/4, which is 1/16. So I can change both of these to decimals. So I have 0.06 repeating, and then 0.0625. So if we look carefully here at place value, we can see that we have a 0 here in the thousands place and a 2. 2 is greater than 0. So our answer here is Kyle has a greater probability. And so again, we looked at each situation separately, figured out their own probabilities, and then compared our final answers.